Hello! In this video, we are going to prove the following theorem. If there exists an x such that p of x, then q. If and only if, for all x, if p of x, then q. Okay, now we're trying to prove a statement containing if and only if. So what we're going to do is we're going to prove if this is true, then this is true. And then we're going to prove if this is true, then this is true. Let's start out by proving if this is true, then this is true. And to do so, suppose this is true. And our goal from here is to show that this is true. Now, since we're trying to prove a statement about every object, let's give ourselves an arbitrary object. I'll call it t. And with t, we want to show if p of t is true, then q is true. So let's suppose that p of t is true. And from here, we want to show that q is true. Now, since p of t is true, there is at least one object which satisfies p. So there exists x such that p of x. But we know if there exists an x such that p of x, then q is true. So these two statements tell us that q must then be true. So putting this together, we see that under the assumption p of t is true, it follows that q is true. Therefore, if p of t is true, then q is true. Since t was arbitrary, this means we have shown that this is true no matter what t is. So we have shown for all x, if p of x, then q. So we have proven if this is true, then this is true. Now we're going to prove if this is true, then this is true. And to do so, suppose this is true. And from here, we want to show that this is true. Now we're trying to show if there exists an x such that p of x, then q is true. So let's suppose that there exists an x such that p of x. And our goal from here is to show that q must then be true. Now, since there exists an x such that p of x, what this means is that there is at least one object out there which satisfies statement p. And I'll call that object c. But let's remind ourselves that this statement is true. And this statement works for every object. So it must work for the object c. So taking x here to be c, we have that if p of c is true, then q is true. But since p of c is true, and if p of c, then q, these two statements tell us that q must then be true. So putting this together, we see that under the assumption there exists an x such that p of x, it follows that q is true. Therefore, if there exists an x such that p of x, then q is true. So we have shown if this is true, then this is true. And we have proven both directions of the if and only if. So we've proven this entire statement. So this completes the proof. And so yeah, that's pretty much it for this video.